As a first simple example of the ranked retrieval model, let's consider scoring with the Jaccard coefficient. So the Jaccard coefficient is a commonly used measure for the overlap between two sets A and B. And what it is simply you take the number of items in the intersection of A and B and you divide it by the number of items in the union of A and B. And so if we take the Jaccard coefficient of a set with itself, then the set has some size, and then that size will be also the size of the intersection, the union, and so the ratio will be 1 and the Jaccard coefficient is 1. If two sets are disjoint and have no members in common, then the numerator of the Jaccard coefficient will be 0, and so the Jaccard coefficient is 0. Now the two sets don't have to be the same size, but you should be able to see that the Jaccard coefficient will always assign a number between 0 and 1, because at most the intersection can be as large as the union. So suppose we decide to make the query document match score the Jaccard coefficient computed for the sets of words that the two documents contain. So the idea is that let's suppose our query is Ides of March, which has these 3 words, and then we have these 2 documents. So what we can do is say, so there are 3 different words here, and then for document 1, Caesar doesn't occur in it, died doesn't occur in it, in doesn't occur in it, March does occur in it. So the size of the intersection is just 1 word, and the total number of words is 6. If we then do the second document, well, the doesn't occur in the query, long doesn't occur in the query, but again, March does occur in the query. So this time, the Jaccard coefficient of D1, comma D2 is going to be 1 divided by the number of words, which is this time 5. Okay, and so this document is going to win as having the higher Jaccard score. Now, of course, that difference may not seem very significant. Essentially, this document is winning here just because it's shorter. But if we imagined a different example where we maybe had the word Ides in the second document, then we'd get that the Jaccard coefficient for it is now 2 overlapping words over 6. And that maybe makes more sense to you, that you're getting more overlap, so the Jaccard score is higher. But this idea that all else being equal, a shorter document should be preferred is a common one that we'll see again in IR models. Okay, so is Jaccard scoring a good idea for a retrieval model? In general, it's not felt to be. It has a couple of issues. One is that it doesn't consider term frequency. It just uses the set of words in a document and ignores how many times the words occur in a document. But that's typically not all the information we want. And we'll look at models in a minute that do deal with term frequency. There's also a second finer point, which is that rare terms in a collection are more informative than frequent terms when evaluating a query, and that's something that we'll also want to factor into our models. There's one other aspect in which the Jaccard coefficient turns out not to work very well, and that is the way in which it does normalization by dividing through by the union isn't necessarily quite right. I mean, in particular, later on in these segments we'll introduce the idea of using cosine similarity. And we'll go through the math of that for the more general case. But if after you've seen that you want to kind of come back to this and work out what the cosine similarity score is, if you just have a 1-0 bag of words and work out a cosine score, it'll turn out that it's this, which is like the Jaccard coefficient, except that we've got this slight difference in the denominator, that we're now taking the square root of the union. And that actually turns out to be a better form of length normalization. Okay, so I introduced the Jaccard coefficient just as a very simple example of a ranked retrieval model, but I hope it was also a way to show some of the issues that we need to deal with in a good retrieval model, how to factor in the frequency of terms, the rareness of words, and how to normalize the score for different document lengths.